we're covering the section polar coordinates. So you are familiar with identifying the position of 2D points in the Cartesian plane using x and y coordinates, where x and y are real numbers. So when we use Cartesian coordinates, for example, let's say I give you 2 and 1, you know how to plot this point. You draw a Cartesian plane. You know that 2 represents your x value, so you go 1, 2 units to the right, and then 1 unit up for the y value, and then you'll plot the point 2 and 1. So polar coordinates are similar to Cartesian coordinates in that they identify the position of a point in 2D space. However, polar coordinates are different because they use the length. Okay, they use the length of that point from some reference point, and they use the angle associated with that point. We'll examine that in a bit more detail just now. Just so you know, the length is called r. So r is associated with the point that we plot, and that's the length. And theta is going to be associated with the point we plot, and that is going to be the angle. So let's take a look at the polar coordinate system. So I want you to take a look at this diagram. What we have is the y-axis and the x-axis. That's straight from the Cartesian plane. But what we do is we call the positive part of the x-axis the polar axis, okay, which can be thought of as basically the positive x-axis. We're not changing anything. We're just basically giving the positive version. So here's the x-axis from the Cartesian plane, this thing that I'm highlighting in red. And then we're taking the positive portion and we're calling it the polar axis. That's all we're doing. Now, let's consider a point P on this polar coordinate system. So there's the point P. I've circled it in red. It's that black dot there. And this point P has an associated r and theta value attached to it. Let's examine in a bit more detail what this r and theta actually mean. So let's look at r first, the first piece of information for this point. So r represents the distance of the point P from the origin O. So here's the origin, right? And r is the distance from the origin to the point P in space. That's why it's called a length, or basically a distance. That's r, super easy. Let's look at theta. So theta represents the angle measured in radians. Okay, it's not in degrees, it has to be in radians. So theta represents the angle measured in radians from the polar axis to the line OP. So the line OP is this line here. You just connect the point that you plotted to the origin. And very important, this is why we called the positive x-axis the polar axis and gave it that specific name, because theta is dependent on this. Theta is the angle measured from here. It has to be from the polar axis, or the positive x-axis. It can't be from this portion, or this portion. It has to be from the polar axis, the positive x-axis. So theta is the angle measured from here all the way to the line OP. Okay, it's basically the angle. It's this angle here. So that is theta. Here's theta. Okay, so theta is the angle from the polar axis to the line OP. All you do to get OP is take that point and connect it to the origin. So that's theta. There are your two pieces of information. R is the length and theta is the angle. So let's get some practice and start actually plotting points on the polar axis. All right, exercise 1. So I want you to plot the following points on a polar axis. If you want to try it on your own, you can pause the video now. Otherwise, I'd like to do this example with you since it's maybe the first time you're encountering it. So let's do this. Let us draw the polar axis. Okay, there's it go. There it is. Here's the origin. Okay, and there's the polar axis. What you can do is you can draw the entire Cartesian plane if you want to, if that helps you, and then at the end just erase it and leave your polar axis. Okay, it doesn't make a difference. If it helps you, you can do it. Sometimes the Cartesian plane helps me in the sense that I know where the angles are. So I know that this is 0 degrees, this is 90 degrees or pi over 2, this is 180 degrees or simply pi radians, this is 270 degrees or 3 pi over 2, and this will also become 2 pi. So it just helps me in that sense. In fact, let's leave it on and then I'll erase it later. So let's plot the first point A. So remember, with polar coordinates, we no longer have x and y values, we have r and theta. So A has a radius of 3, so its distance away from the origin is 3, and then the angle or theta value it has is pi over 4. So let's get the angle first. The angle is the most important thing, and then your distance you can just, in terms of a drawing, you can make it how far away from the origin that you want. Okay, so pi over 4. Here's pi over 2. Here is 0. Pi over 4 is directly in the middle. If you're having trouble seeing that and thinking in terms of radians, what you can do is convert the pi over 4 into degrees. Maybe that will help you. So you just times this when you are going from radians to degrees, times it by 180 degrees over pi. So you'll get 180 degrees over 4. 180 over 4 is 45. So 45 degrees, that's this angle here. That's 45 degrees, pi over 4 radians. All right, so there's 45 degrees. Let's plot point A. Let's make three somewhere here. Well, let's make it here. All right, there's point A. So that's going to be 3 and pi over 4. All right, that's point A. Let's go for B. So B is 2 and 3 pi over 2. So 0, pi over 2, pi, and here is 3 pi over 2. 3 pi over 2 in terms of degrees is 270 degrees. So we're going to be on this line here, okay, on that line there, and we have a length of 2. So let's plot that in blue. That would look somewhere here. So it would be closer to the origin compared to point A. Okay, let's plot it there. Okay, so that distance, compare it to that distance. This distance is 3 units, that distance is 2 units. Okay, this is going to be point B, that's 2 and 3 pi over 2. All right, let's do point C. So point C now has a negative distance. So again, when you are plotting these points, what I want you to do is start with the angle. Get the angle right, and then you can look at the length. How do we plot a negative length? Let's worry about the angle first. We have 5 pi over 6. 5 pi over 6 in terms of degrees is going to be 150 degrees. So here's 90 degrees, here's 180. Then you have to divide this into 3 sections. So 120, 150. So 150, the 150 line is here. Okay, so it is there. Let's get that there properly. There we go. Let's use a different color. Let's use pink. This is how you plot something that has a negative r value. Pretend as if that r is a positive value. Just take the positive version. So it's not -1, it's +1. So +1 would be there. Now, because it's negative, what you're going to do is you're going to extend this line down. So you see the 150 line here, just extend it down, okay, across, and then plot +1 here. You're basically reflecting this on the other side. That's all you're going to do. I'll do it one more time. So if you have a negative r value, find the angle. Here's 150, and you plot with a positive r value. So plot a +1. Then this 150 line that you drew, just extend it. Just extend it with a ruler, whatever you're using, and then plot 1 here. I think 1 would be somewhere here though, okay, because this is 2. So, and that will be C minus 1, 5 pi over 6. And that's how you plot negative R values. All right, let's do the next one. So we have D, that is 4 and minus pi over 4. So what happens now when we get negative angles? This is how we're going to plot D. So like I said, start with the angle. So positive angles are measured this way. Okay, they're measured anti-clockwise. Negative angles are now measured clockwise. So if I had to plot positive pi over 4, it would be here. But if I'm going, because that's a positive angle, pi over 4. If I'm going to plot a negative angle, then I'm going to go clockwise. So negative pi over 4, that's basically minus 45 degrees. So we go minus 45 degrees that way. That is on this line here. That's negative pi over 4. Then we're just going to go 4 units along this line, and that will be somewhere, let's use yellow, that would be somewhere here. So that would be point D. That would be 4 and minus pi over 4. There we go. Okay, let's go for point E. So point E is a bit interesting because it has a negative r as well as a negative theta value. So again, let's start with the angle. Pi, let's start with pi over 6. Pretend it's pi over 6. Pi over 6 in terms of degrees is going to be 30 degrees, but it's a negative angle, so we will work our way clockwise. Negative 30 degrees is somewhere, so if this is 0 degrees and we had to treat this as 90, basically, 30 would be here, and then 60 would be here. So 30 is along this imaginary line. So let's plot. We have minus pi over 6. There's our line here, minus pi over 6. Let's plot positive root 2. So positive root 2 would be somewhere, would be, let's see, let's plot it in red, would be somewhere here. But it's not a positive root 2. So what we have to do, because it's a negative root 2, is extend this line and then basically just mirror this point along this entire line. So it would become somewhere here, and that would be the point E. That would be negative root 2 and minus pi over 6. There we go. Okay, let's do the last one. F, we have 1 and 5 pi. So 5 pi is a bit interesting because it's greater than 2 pi, so you may be thinking, how am I going to handle this? Let's just go through it step by step. So 5 pi. 5 pi is 2 pi, so we'll go 1 revolution. And then it's another 2 pi, so we'll go another revolution, all right? And then how much do we have left? Well, we have pi, so let's go pi units here, 180. So we are going to end up, even though it's 5 pi, we are still going to end up on this line, the pi line, 180 degrees. And then r is 1, so we just go 1 unit out. Let's plot it in blue. 1 unit out should be somewhere here. There we go. So that would be the point F, that's 1 and 5 pi. Okay, and then when you're done with all this, you can just remove the x and y portion and just leave the polar axis. If you want, you can connect these. It just shows you where each point actually is. So that's how you handle this example. That's how you plot polar coordinates. Always start with the angle. Always start with the angle. Remember, if it's a positive angle, you're going anti-clockwise. If it's a negative angle, you're going clockwise. Then plot your R. If you have a positive R, great, plot it as is. If it's a negative R, just extend your imaginary drawing line and plot the mirror image on that imaginary drawing line. So that's exercise 1. Now, let's examine the connection between Cartesian coordinates and polar coordinates, because again, they do the same thing, they have the same function, plotting points in two-dimensional space. So there needs to be a connection between Cartesian coordinates and polar coordinates. In fact, why are we actually using polar coordinates? It's just sometimes expressions can be easily plotted and graphed and understood in polar coordinates instead of Cartesian coordinates, because these may become too complicated for some functions. So that's why we have polar coordinates. Now we need to examine the relationship that relates the two, because they basically do the same thing. They have the same function, plotting stuff in 2D space. And that relationship that I'm talking about, it can be seen easily using the following diagram. So let me just break this down. Here's the y-axis, here's the x-axis, and remember the positive portion is called the polar axis. Okay, nothing mind-blowing, they just gave it that name. Here's the origin, O, and here's a point, that black dot, that's the point P. And in polar coordinates, it has an r and theta value associated, but in Cartesian coordinates, it has an x and y value associated with it. Again, it's still the same point. How now are we going to relate this r and theta to the x and y. How do we relate the two? And we relate the two by drawing a triangle and using the theorem of Pythagoras and some trig ratios. So here's a point P and it has an x and y. Remember, x is your distance from your horizontal distance and y is your vertical distance. And then we connect the origin to the point P, and remember in polar coordinates, the length of OP is r. So this entire distance is r. Also in polar coordinates, we have a theta, and theta is from the polar axis to the line OP. So there we have theta. So let's look at the equations now that relate polar and Cartesian coordinates. Okay, don't worry about using equations 1 and 2 and using equations 3 and 4. I'll explain that just now. Let's look at how these equations are derived so you remember them and you don't have to memorize them. X is equal to r cosine theta. So let's look at, so we have cosine theta involved. Let's look at cosine theta. So here's theta here. Here's theta. Cosine is adjacent over hypotenuse. So here's the adjacent, x. Here's the hypotenuse, r over r. And then we take the r over onto the other side. So we multiply the cosine theta by r, and we get r cosine theta is equal to x. X is equal to r cosine theta. That's how we get the first equation. And I'm sure you can see how we get the second equation. Same logic. We have sine theta. Sine theta is opposite over hypotenuse. Opposite is y. The hypotenuse, this looks like an x. Hold on. There we go. The hypotenuse is r. And what we're going to do is take that r over and multiply it on that side. And what we'll get is y is equal to r sine theta. So that's how you get equations 1 and 2. Let's examine this. In general, use equations 1 and 2 to convert from polar to Cartesian. So let's say I give you r and theta, and you want to say, hey, what's the x and y values? What's the Cartesian coordinates? Well, you have the r and theta, so plug them into the right-hand side of these two equations, and you'll get your corresponding x and y value. Okay, so in general, use equations 1 and 2 to convert from polar to Cartesian. Let's look at equations 3 and 4. So equations 3, r squared is equal to x squared plus y squared. That's super easy. Come on, that's Pythagoras. Okay, the hypotenuse squared is equal to x squared plus y squared, the sum of the other two sides. Okay, squared. Then let's look at equation 4. Tangent theta is equal to y over x. Again, that's his trig ratios. So tangent theta, tangent is opposite over adjacent. Here's theta, here's the opposite, here's the adjacent. It's y over x. Again, this doesn't look like in y. There we go. All right, so let's look at this. Use equations 3 and 4 to convert from Cartesian to polar. So let's say you have the x and y value of this point P. You have the Cartesian coordinates, and you want to find out, well, what's the polar coordinates? So you just sub in for x and y, sub in for x and y, and you'll get r squared. But remember, you want to solve for r, and then you'll get tangent theta, and you can obviously solve for theta using the inverse tangent function, arctangent. So those are the equations that relate polar and Cartesian coordinates. Let's apply these equations in practice. All right, exercise 1. So I want you to convert the point 4 and 3 pi over 2, so that's a polar coordinate, convert it into Cartesian coordinates. Okay, let's go for it. So what I advise you to do whenever converting polar to Cartesian or Cartesian to polar, always sketch this first. It's always nice to just sketch it first and to check that your the Cartesian or polar coordinate that you get, it actually makes sense and it matches with what you've sketched. So let's just make a quick sketch. It's 4 and 3 pi over 2. Let's do the angle first. So 3 pi over 2, that's here. So it's on this line here. And we are 4 units out. So 4 units out somewhere here. So that is the point in polar coordinates. Let's use the equations now. Remember, we need to use equations 1 and 2 to convert from polar to Cartesian. So x is equal to r cosine theta. So r is 4 cosine 3 pi over 2. Now, you aren't using a calculator for this example, so how do you get cosine 3 pi over 2? This is what I do. I just sketch the cosine graph. And I remember that all the important points go in steps of pi over 2. So 0, pi over 2, pi, 3 pi over 2. So 4 multiplied by 0 is equal to 0. Cosine 3 pi over 2, there's 3 pi over 2x, and that gives us a y value of 0. So x is equal to 0. So far, so good. Okay, this point is 0. Let's deal with the y value. So the y value, we will have y is equal to r sine theta. That's equal to 4 sine 3 pi over 2. Let's sketch the sine graph. So the sine graph looks like that. Important points go in steps of pi over 2. So 0, pi over 2, pi. Here is 3 pi over 2. That gives us minus 1. So it's 4 multiplied by minus 1. That's minus 4. And excellent. There we go. This point in Cartesian coordinates, we can see that it is, in fact, 0 and minus 4. So that's the answer for exercise 1. 4 and 3 pi over 2 is 0 and 0 and minus 4 in Cartesian coordinates. All right, that's exercise 1. Exercise 2. I want you to represent the point 2 and 3, so that's in Cartesian right now. I want you to represent that in polar coordinates, where the theta that you have is between 0 and pi over 2. I also want you to use a calculator to determine the value of theta. So let's go for it. So let's use equation 3 and 4 to convert from Cartesian to polar. And before we even use the equations, let's plot this point and see what we are trying to get. So it says that point 2 and 3, that's obviously somewhere here. So that's 2 and 3. And take important note of the restriction where theta is between pi over 2, that's basically 90 degrees. So it's between 0 and 90 degrees, or 0 and pi over 2. So it has to be, obviously, in this first quadrant here. And the reason why we have this restriction is because it's going to restrict our theta and it's going to restrict our r. So let's work with r first. R squared is equal to x squared plus y squared. Okay, we can see that x is 2 and y is 3, so 2 squared plus 3 squared, that's 4 plus 9, that's 13. So r is equal to the square root of 13, so that's plus minus root 13. Now, let's deal with this plus minus root 13. So the point has to be here. It has to be between 0 and 90 degrees. Now, if, let's just say theta is, I don't know, let's say it looks like maybe it's 75 degrees, maybe 65 degrees. If r was negative, how we'd plot this point is on 75 degrees, we plot the point there, and then we'd have to reflect it and move it down here. So if it was negative r, it would end up in the third quadrant, and that's not what we want. Okay, so we actually need to choose a positive value of r. Why? Because this point lies in the first quadrant. Okay, so it lies in Q1 because the point lies in quadrant 1. Now we'll deal with theta. So r is equal to root 13. Okay, that is equal to 13. There we go. Then we'll deal with theta. So tangent of theta is equal to, let's see, y over x. So y over x, that's equal to 3 over 2. So theta is equal to arctangent of 3 over 2. And I said you can use a calculator. You get 0.9828 radians. Okay, so that is how we represent the point 2 and 3 in polar coordinates. So we have root 13 and 0.9828 radians. That's example 2. So I want you to take a look at these 4 equations again. Equations 1, they convert from polar to Cartesian. Equations 2, they convert from Cartesian to polar. When we use equations 1 and 2 to convert from polar to Cartesian, we will obtain a unique answer. That means we'll only obtain one single answer. You only obtain one why am I saying possible? One possible x and y coordinate pair. That's why it's unique. You only get one single answer. However, when we use equations 3 and 4 to convert from Cartesian to polar, we can obtain many different but still valid answers. Okay, so we can obtain, there are an infinite possible number of answers that you can get, but they are all valid. Why is this the case? Okay, theta can increase and decrease indefinitely because it is an angle. For example, let's say I wanted to represent this point. Uh, let's say that point was 2 and pi over 4. What I can do, so this is pi over 4, right? What I can do is just add 2 pi again, and I can get the point 2, and let's see what it would be. It would be 9 pi over 4. Yep, 9 pi over 4. This and this, they represent the same point. And then I can add another 2 pi to this, okay, and I would get 2, and let's check 17 pi over 4. Okay, it would represent the same point. So I can keep adding 2 pi, I can even subtract 2 pi all the time and go into negative angles. But the point is I get an infinite number of answers that represent the same point in space. That's why when you use equations 3 and 4, they may not just give you a single answer. You can get numerous different answers because theta can increase and decrease indefinitely because again it's an angle. And you've seen that r can be positive or negative, so you can get different answers. So this means that when we convert from Cartesian to polar, you must sketch a diagram to check if your answers are valid. I always tell you to sketch a diagram because that helps you to see what you're actually doing instead of just applying formula blindly. So always start by sketching a diagram when you're doing these conversions. All right, exercise 3. I want you to represent the Cartesian coordinates 1 and negative root 3 in polar coordinate form. And I want you to get two answers for this. One answer must have r less than 0, so it must have a negative length or negative radius, and the other must have a positive radius where r is greater than 0. All right, let's do this. So again, we're going to start off with a sketch. Always start off with a sketch. So Cartesian coordinates 1 and negative root of 3. So here's 1, negative root 3 is somewhere here. So we can see that we have a point that is in the fourth quadrant. Okay, so that's 1 and negative root 3. Now let's apply the formula. So let's start off with r. So r squared is equal to x squared plus y squared. That's 1 squared plus negative root 3 squared. That's going to be 1 plus positive 3. That's 4. So r is equal to the plus minus square root of 4. That's equal to plus minus 2. Great. Now we have a positive r and we have a negative r. Let's deal with our angle. So angle is going to be tangent theta is equal to y over x. That is going to be negative root 3 over positive 1, which is just negative root 3. So theta is equal to arctangent of negative root 3. And if you use the special angle trig tables, okay, you're going to find that theta is equal to minus pi over 3 plus k pi. And I'm including this plus k pi to account for the periodicity of the tangent function. Remember, the tangent function, it repeats its value every pi radians, basically every 180 degrees. Why am I doing this? Again, because we want two possible answers. I want one with a positive radius and one with a negative radius. And we're going to make that possible by using different values of theta as well. So let's look at this. Let's copy this diagram here. Let's put it here. Okay, so let's say I want to have a positive radius. So positive radius there, this needs to be 2 units. Then I need to measure the angle moving downward. So I need to include a negative angle. And clearly, I will get a negative angle when I take k to be 0. So I'll get negative pi over 3. All right, so we're going to choose k is equal to 0, and theta will equal to negative pi over 3. So 2 and negative pi over 3, let's just check if that works. Let's check if our logic works. So negative pi over 3, that's about negative 30 degrees. So we go negative 30 degrees, and then we plot 2 units along, and we will end up getting that point that we want. Then let's say I want negative 2, I want negative radius. What needs to happen? So if it's a negative radius, it means I need to end up somewhere here. And when I plot it, I need to extend that imaginary line. And because it's a negative 2, I'll be coming back here and plot it there. So I basically need to plot this point first, and then because it's a negative 2, I'll come back and plot it in the actual place that I want. So I need to find this angle. And I'm sure you can see that if I choose that angle looks to be greater than 90 degrees. So what if I take k is equal to positive 1? So k is equal to positive 1. It will give me an angle of 2 pi over 3. That is, let's check, 120 degrees. Yep, it's greater than 90 degrees. So we will choose 2 pi over 3 as our second theta value. And yes, there are numerous other answers you could get by choosing different k values, but again, these are the simplest ones to obtain.